Okay, example E. We need to rewrite this in the proper format for analyzing and graphing using transformations. So I am going to do that before we start figuring out all the transformations that we need. On the inside of the function, I cannot have that 1/2 directly next to the x. So I'm going to factor it out of the underneath expression. And when I say it, I mean the 1/2. I'm going to factor the 1/2 out of that underneath expression. And so when I factor the half off, I get x plus, and you got to be careful here because when you take your 2 and you factor out a half, you're really dividing by a half, and 2 divided by a half is actually 4. So be careful with your math on that. You get x plus 4. And go ahead and distribute that 1/2 back through, and you will see it will give you 1/2 x plus 2. And then I just got to copy down my -3, and then we're ready to analyze. The easy things are the shifts, and this -3 is actually a downshift, and the +4 is a left shift. Remember, on the outside of your function, that's your up-down movement, and whatever the sign is, that's what you're going to do. If it's plus, go up. If it's minus, go down. And then your left or right shifts on the inside of the function, and it's opposite of what you think it should be. When you see +4, you go left, and when you see -4, you go right. And then before we do the other analyzation, I'm going to go ahead and write down the table for the parent function. Now, when you're doing your homework or you're working on problems, you do not write down the original table. The only reason I'm doing this is for teaching purposes and so you can visually see what I'm talking about. And as I discuss what our transformations are, you can see that in the numbers off the original table. So our square root function has x values that go from 0 to 1 to 4, and that's it. If you wanted to do another number, it would be 9. It would be another perfect square, but this is all we really need to get the basic shape of our square root function. And our y values are 0. The square root of 1 is 1. The square root of 4 is 2. And that's all we typically use to graph. Now, the other transformations that I haven't talked about. First of all is the 1/2 x, or the 1/2 in front of the x. That is going to be a horizontal compression or stretch when the number's being multiplied on the inside of the function, and it's opposite of what you think. Your horizontal movement is the x numbers and off the x-axis, and instead of having them, it's going to be the opposite. It's going to double them. So instead of dividing your x's by 2, you're actually going to multiply those x's by 2. And so I'm going to take my x values and double them. You get 0, 2, and then 8. So it's going to make my x movement twice as far out as it normally would. It's going to be a horizontal stretch. I'm going to bring each x out farther than it normally was. And then we have the number on the outside, that 2 on the outside, and that affects your vertical movement. And it's going to do what it says it's going to do. If you are timesing by 2, it's going to take your vertical or y numbers and it's going to times them by 2. It's going to do exactly what you think, not the opposite. So vertical stretch, it's going to double those y's, and then I get 0, 2, and then 4. And then I look to see if I have any reflections, and I don't, so this is it. This is all we got. All of those old x and y's that you would use for your regular graph are no longer going to be used. These are the values that you use when you graph your new function using transformations. And these ordered pairs are off your new origin. I just want to say it doesn't go off the original origin. It's once you move your left, right, up, down shift and you create that new origin, then you use these ordered pairs off of that new origin. So let's go ahead and find our new origin. Our new origin is going to be to the left 4 and then down 3. This is our new origin. Never ever will you look back at the old origin. You don't even look at the numbers anymore that are written on your original XY axis. You just pretend they don't exist anymore. The ordered pairs in my table over there are not going to correspond to the original XY axis. These numbers are going to correspond to my new origin, which would be 0, 0, 2, 2, and then 8, 4. So let's go ahead and, without really looking at that table because I want to ignore it for now, I'm going to go ahead and graph just by thinking through everything that's on here. So I took care of my shifts, and then normally my first order pair is 0, 0. That's not going to change for the square root problem. And my next movement would be over 1 and then up 1, to the right 1 and up 1. Well, my horizontal movement can no longer be to the right 1. It's going to be double whatever that is. So instead of going over to the right 1, I'm going to go over 2. And then my Y movement is normally up 1, but I'm also going to double that amount right here. So instead of over 1, I'm over 2. And instead of up 1, I'm up 2. Both of those are going to get doubled. Okay, and then the last ordered pair that I use is normally over 4, up 2. Over 4, up 2. But instead of going over 4, I need to double it. So I'm going to go to the right 8. 1, 2, 3, 4, 5, 6, 7, 8. And normally I'm over 4, up 2, but now I'm going to be over 8, up 4, because I need to double my original ordered pair's Y value, which is normally 2, but now will be 4. So it's right there. So when I'm graphing, I don't look at the XY table. I'm doubling and halving and tripling and fourthing, and I'm multiplying everything in my head. It's kind of hard to keep track of, but when you do enough of these and you actually have your original tables memorized, it's actually not that bad. Okay, so let's go ahead and look at my order pairs right here and see if we did it. If I'm using my table down below here and my new origin, and my over 2 up 2, yep, and my over 8 up 4, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, yep. All of this is supposed to be done in your head and not actually, drawing out the chart, because it's just too time consuming, and it kind of looks like a hot mess over here when I actually change all the numbers in the table. So you want to do your best to try to memorize your parent functions and then also make those changes on each one of the original ordered pairs one by one as you're plotting them.